Hi everyone, we are the Autopilot dashboard team and we'll be presenting on our second sprint. First, we'll be talking about how we set up Autopilot with Kubernetes. So first, we created a local Kubernetes cluster with worker nodes using kind. Then we install Autopilot with custom Helm chart configuration file, which allows the Autopilot to run on non-GPU nodes.
We also patched the daemon set to run as root, and then we finally observed Autopilot deploy a pod for each of the worker nodes because it is a daemon set, and these pods were able to run health checks and also label the worker nodes with the GPU health equals pass label as shown in the image below. For the testing page, we did set up the basic functionality of the front end. We have a drop-down menu allowing users to select a set of health checks to be run. We also have drop-down menu for the nodes, which the tests will be run on. And we have a button for select all nodes, select all worker nodes, and a button for select all tests. Once the user has decided on a set of health checks and a set of nodes, they will press the run tests button, which will just submit the tests job to Autopilot, and Autopilot will return the results of those tests in a text string format shown in the embedded terminal window below.
Users can also turn on the batch switch, which will enable the box below, and they will enter the batch number that they would like.
In terms of the backend, we implemented very basic list nodes method, which just fetches a list of all the worker nodes on the cluster using the Kubernetes API. This is for the select nodes drop-down menu. We also implemented the main run tests method, which takes a set of selected tests and a set of selected nodes, and then runs the tests on those nodes by making a request to Autopilot's RESTful API, its /status endpoint with those parameters. And as Ryan mentioned, there's also an optional batch parameter, which allows users to select how many hosts are being checked at a single moment. The requests to batch are run in parallel asynchronously, and the default is all nodes are checked at a single moment. But with the batch parameter, you can split it up into batches, and you can avoid running too many requests in parallel with a lot of worker nodes. And finally, the result of the method is just that it returns the tests results as a text string shown in the previous slide.
For the monitoring page, we set up a table that shows all the cluster nodes and status and information about them. We also have a search bar that you can input a search query into, which then filters the table to show only the nodes that have the matching name to the query that you put in.
Following would just be the collapsible table for the monitoring page. It shows this following main information about nodes, and when you click on the expand table, the next slide will show the extra information regarding the capacity and the allocatable resources. Thank you. And regarding the backend, we implemented the function called use nodes with status that uses the Kubernetes API to fetch information regarding the nodes on the cluster. So we utilized a custom hook that automatically updates and revalidates information that was being fetched. And we also read the node labels that was provided by Autopilot services regarding the GPU health.
So I built the front end for the login page, and it allows only for administrators to run tests securely. And future demos will introduce OpenShift login for easier access for the admins.
Following will be the burn down chart for our current sprint, and as shown by the yellow line, we also went below 0 because the team spent extra hours to finish up the task. Next will just be the detail of our second sprint, and as you can see on the this slide, where we are almost accomplishing every task that we have, except for one on the backlog, which because the mentors told us not to prioritize this, so this will be pushed to the next sprint. And this will be a screenshot of our backlogs.
In terms of challenges encountered, one was with setting up Autopilot. There was an error in the official IBM Autopilot README, which was causing some of us difficulties in the setup process. but I submitted a pull request on the Autopilot repo correcting this, and it got approved. So the README is updated now for the future.
We also had to become accustomed with Kubernetes, kubectl, and kind, as most of us had never used this before. So getting familiar with this was a process that we had to go through.
In terms of setting up the web application, we had to set up the Kubernetes endpoints, which took us some time reading the documentation to figure it out. And we also had to address a allow CORS issue, which the temporary fix we did for the development was just download a CORS Chrome extension and allow CORS Chrome extension, which temporarily fixed it. But in terms of, for production, we're either going to have to update the Autopilot backend to allow CORS specifically from our application's URL, or if our application and Autopilot is on the same cluster being hosted on the same domain, the CORS issue won't even come up because it's on the same domain.
Another issue with web app setup was the learning curve of learning how to use the Kubernetes API, because we need to get real-time data from all the nodes, and then we need to get all the information and labels for each of the nodes with Autopilot. And then we fixed this issue by thoroughly understanding the documentation of the Kubernetes API. For lessons learned was setting up the Kubernetes API to and learning how to understand all the configurations and setups when we're setting up Autopilot and the dependencies needed for it. And when we have unexpected challenges, it's good to work around them and find a different solutions to the challenge. For web app setup, we need to learn how to properly set up cloud-based web apps to follow the proper protocol and policies for networking and security. And then we learned how to handle the API responses and how to configure them and get the information that we needed out of them.
We were also able to truly see the value of the vertical slicing approach, as we were able to show a basic implementation of our dashboard to our mentors earlier this week, and we were able to get real-time feedback, and we're going to incorporate them quickly into our upcoming sprints. Some key feedback that we got this sprint was to build an image of Autopilot rather than pulling from the repository.
We also got several points of feedback on the testing page. First one was, instead of horizontally laying out the control panel and embedded terminal, make the layout be vertical. This way it'll allow for a longer terminal window, taking up the whole page. Also, currently the DCGM and iPerf tests are set on default values, but these tests can be parameterized to other values. So it would be good to have an additional dropdown or feature to allow further parameterization of these tests. And of course, the final thing which we will add is select nodes based on features rather than scrolling down to select the nodes. There should be various filters for the nodes which users can select, have that set.
The monitoring page, our mentor said that we should remove the runtime version and OS from the table, and instead it's more important to show more information about the GPU, like the GPU number changes, the resources, the type, and then more information about the health of each GPU.
So for the next steps for our third sprint, aside from addressing the feedback points that was given to our mentors based on the previous slide, we want to improve the styling and responsiveness of our web page, and then update the methods that we use to fetch information from the API using Kubernetes Watch, then apply node filters for monitoring and testing page. Additionally, implement a Kubernetes cluster authentication for login page. Then we also want to package the web app such that it operates in the same container and utilize MOC resources. By this, we conclude our Sprint 2 demo, and we are ready for any questions and feedbacks. Thanks, everyone.
Yay!